All right, number 3, the formula for the volume of a square pyramid is V is equal to base squared times the height divided by 3, where B is the length of one side of a square base and H is the height of the pyramid. Find the length of a side of the base of a square pyramid that has a height of 3 inches and a volume of 25 cubic inches. Now, I've told you guys on word problems that you have got to look for the question. Find the length of a side of the base of a square pyramid that has a height of 3 inches and a volume of 25. And what else is important? The formula. So V equals base squared times the height divided by 3. They gave us the height is 3, and they gave us a volume of 25. So 25 replaces the V equals B squared, they did not tell us the base, times the height, which is 3, and then we divide by 3. When we divide 3 by 3, it's going to eliminate, leaving us with B squared equals 25. To cancel out a square, we have to take the square root. If we take the square root on the right, we have to take the square root on the left, which will give us B equals 5. So our square pyramid has a base side length of 5, and it is in inches. Okay, 5 inches. Number 5. The base of a cube is shown. The area of the base is 1/4 feet squared. What is the volume of the cube? So they are giving us area. Gave us area. Area equals side squared. They want to know the volume, and volume is side cubed. There is no way to go from a side squared to a side cubed unless you go to a single side. So we need to go from a square to a single side, and then we'll cube that number. So we'll plug in our area, which is 1/4. To solve for S, we're going to take the square root of S squared. If we square root on the right, we square root on the left. The square root of S squared is S. The square root of 1 is 1. The square root of 4 is 2. So the side length is 1/2 of a foot. Now to find the volume, we plug that in. Volume is equal to 1/2 cubed. Remember that you have to distribute this exponent top and bottom. So the 1 gets cubed. 1 times 1 times 1 is 1. The 2 gets cubed. 2 times 2 times 2 is 8. And that's going to be feet cubed. Lesson 3 was rational and irrational numbers. The main thing you needed to be able to do from this lesson was this problem on number 21, which is identify rational versus irrational numbers. Those other categories were review from last year. Now, we have to decide on a category. Irrational numbers are numbers as a decimal. They do not repeat and they do not terminate. It's just random numbers that go on forever. Now, rational numbers are basically everything else. It's all of your whole numbers, numbers that don't have a decimal. 0 is a rational number. All of your negative whole numbers. It is also any number that can be written as a fraction, which all of your whole numbers can. Any decimal that repeats, and any decimal that terminates. Lots of different numbers become rational numbers. Now, the square root of 50 is not a perfect square. And if you remember, those imperfect squares, they do not ever work out well. So if you had a calculator, you would take the square root of 50, and you would come up with this number. All of those random decimal points makes that an irrational number. Square root of 50 is irrational. 3.456 repeating is a repeating decimal, and all repeating decimals are rational. Okay, it is rational. 0 does not have a decimal. We could write it as a fraction if we wanted to, but regardless, it's going to be a rational number. The square root of 4/9, when simplified, would come out. The square root of 4 is 2. The square root of 9 is 3. It is a fraction, which makes it rational. So the square root of 4 over 9 is rational. 0.38 is a terminating decimal, and all terminating decimals are rational. So we'll put it in the rational box. The square root of 81 is a perfect square. It comes out to 9. That is very much a rational number. So square root of 81 goes in the rational box. 2 times pi. Pi is the most commonly known irrational number. Guys, it is so irrational, they gave it a symbol. If we take this mess of a number and we double it, it is just a mess still. It's just twice as big. Okay, 2 times the mess. Irrational. The square root of 169, you're probably not going to have memorized, but if it was 169, you should know that it is 16, 13. Now, the square root of 1.69 would be 1.3, which is a terminating decimal. So the square root of 1.69 is rational. The last one is the square root of 2 over the square root of 9. The square root of 2 is not a perfect square. It comes out to an irrational number. And if you've got an irrational number in there, it's going to be irrational. Square root of 9 is not irrational, but because the top number is, it's irrational. Part B says circle one of the numbers you said was rational and explain how you decided that number was rational. Now, 0.38 is a terminating decimal. You could have picked any of those numbers. Part C says now circle one of the numbers you said was irrational. I'm going to go with 2 pi. 2 pi is irrational because if you double pi, it is still a non-terminating, non-repeating decimal. Part D says draw a number line and locate the 2 numbers you circled on the line. Write a comparison statement like less than, equal to, or greater than to compare the numbers. Guys, if you're going to have a number line, you have to put some numbers on there. Okay, both of my numbers are greater than 0, so I'm going to start with 0. The biggest number, 2 times pi, that's going to be 6 point something, so I'm just going to go to 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Now, did I have to number them all? No, but I have some reference points on there. Now, 2 times pi, 2 times 3.14 is going to be 6.28. So I'm going to put it right here. 2 times pi is here. The other number I used was 0.38. It's almost 0, so I'll put it there. And then they said to write a comparison statement. 0.38 is less than 2 pi. In a perfect world, you would have probably wrote 0.38 is less than 2 times pi. Solve the problem. Use what you learned from the model. Tell whether you know the following numbers are rational or irrational and explain how you know. Then, well, we can go ahead and do that. The square root of 2 over 8 is going to be irrational because those numbers are not a perfect square. Those are not perfect squares, which means that those decimals are going to go on forever. If you are not sure that you believe me on that, you could type in 2 divided by 8, and you could take the square root of that. Oh, that worked out. Okay, scratch that. They are not irrational. That will reduce. You have to reduce. Gives me 1/4. Those numbers are perfect squares, which makes it rational. Okay, rational. Because it simplifies to a fraction of 1/2. Now the square root of 2.56, that one should be irrational. And it is not either. 256 is a perfect square of, no, 13 would be 269. No, that's 169. 15 is 225. Is it 16? Yeah, it's 16. So the square root of 2.56 comes out to 1.6, which is a rational number because it is a terminating decimal. Write the decimal approximation for each number and place it on a number line. The decimal approximation of 1/2 is 0.5, so we'll put it right here, and we'll put the original format of 2/8, square root of 2/8. And then we've got square root of 2.56 came out to 1.6, which I'll put here between 1.5 and 1.75. 2.56. Okay, so we've done the first one, we've done the second one. And then the last part says, show your work, use decimal approximations, a number line, and words to explain your answers. Okay, so I feel like we just did that. Our decimal approximation as decimals, we got 0.5 and 1.6. And the number line, we put it on up here. And then using words to explain our answer, both numbers are rational because they are terminating decimals. Lesson 4 is scientific notation. The heaviest portion of the test is on Lesson 4 and Lesson 5 on scientific notation. The other 3 are there, just not as much as the scientific notation. Which of the following expressions is equivalent to 5,710,900? They're wanting you to convert this to scientific notation. We want to put our decimal in a place so that we only have one digit left of the decimal. So I want to make my decimal 5.7109. Now, if you wasn't sure about where to put the decimal, notice how all of the answer choices had exactly the same decimal. Now, we have to have a base 10, but all we have to do is count the decimal places. I've got 1, 2, 3, 4, 5, 6. So 5.709. 5.7109 times 10 to the 6 would have been the correct answer. Number 2, the average distance from Pluto to the Sun is 6 times 10 to the 9th kilometers. The average distance from Mars to the Sun is 2 times 10 to the 8th kilometer. The average distance from Pluto to the Sun is how many times as great as the average distance from Mars? Now, looking for the question, they want to know how many times as great as the distance. You just had to decide which one was bigger. Now, you should know which one is the farthest away from the Sun. But if you don't, the way that they word it tells you the average distance from Pluto to the Sun is how many times as great. They're telling you that Pluto is the farther number away. So we want Pluto over Mars. And we just have to substitute those in and solve. Because to find out how many times as great, you have to divide. Pluto, 6 times 10 to the 9th divided by Mars, 2 times 10 to the 8th. We're going to divide the constants. 6 divided by 2 is 3. And then we will divide the base 10s, 10 to the 9th, divided by 10 to the 8th. We're going to subtract using the quotient rule. Gives me 10 to the 1. So 3 times 10 to the 1 as far. They did not specify how they wanted their answer. I'm leaving it in scientific notation because the question was in scientific notation. But if we're just curious and we want to know, in standard form, it would be 30 times. Okay, 30 times.